How are you too? Let's get match. Wow.
So last week we started learning about something. Who can remind us of what we learned? Yes. Set. Let's clap for him. What did we say set is? What is a set? I want different person. Yes. What is a set? Okay, help us. It is a what? A collection of objects. So today we are going to learn about types of set. Okay? I want you all to say after me. Types of sets.
Types of sets.
So we are going to talk about types of. So by the end of this lesson, I want you to be able to know at least 3 types of sets. Okay? You should be able to know at least 3 types of sets. I'm going to ask you when we end the lesson, so that you are going to tell me what you have learned, okay? So, as we learned earlier, a set is a collection of what? Objects of the same kind or distinct objects. So we have different types of sets, okay? We have different types of what? Sets. So we are going to talk about the first one, which is finite set. Everyone say finite set.
Finite set.
Finite set.
Finite set.
So I told you to learn ahead. What have you learned about finite set? When you say finite set, who has an idea about it? Yes. Finite set. I was so taking a class is silent. Finite set, yes. Okay. I hope you are sitting in peace. I want you to think about it. The two of you includes. Think about finite set. I'll call you randomly and then you tell me. So I'm giving you just a minute. Pair with your partner and then think about finite set. Okay? Are you not with me? Are you done? Yes. Your group, what is finite set? What did you learn? Stand up again. You are talking to the audience to amplify your voice. Alright, try your best. Good. Which other group can tell us? Most of them are finite set. So when we talk of a finite set, we are talking of a set whose last element or member can be found. A finite set, because I did be a finite. To say where we are. Please do you understand it? A finite set is a set whose last member can be what? Found. Exactly. So who can give an example of finite set? A set with a last member identifier. And which will be the last member. So you know that the elements that are found in a set will be called them what? The members or the elements. Exactly. So for example, if you get set A, which is 1, 2, 3, 4. So when you look at this set, this is set A. Do you get it? You can see that the last member, what is the last member here? 4. So the last member here can be what? Found. Exactly. So this is what we call what? A finite set. Because the last member can be what? Found. Please do you understand it? Yes, sir. Who can give me an example? I have given my own. Yes. Yes, try. Give me an example of set whose last member can be found. Just any number. Give me any number, any set. Yes. What is the name of the set? Okay. Say maybe set Q. What? A, B, C, D, E. Let's clap our hands for it. So, looking at this set that she has given, we have what? A, B, C, D, and what? E. How many elements are here?
5.
How many elements are here?
5.
Good. So, can we see the last member?
Yes, sir.
Can we see the last member?
Yes, sir.
Good. So, this is what we call what? This is what we call what? Finite set. Do you understand it?
Yes, sir.
Good. Let us write something. Finite set. Write something. Example. Set A is equal to 1, 2, 3, 4, 5. And then so we've got to know that set A has 5 elements, okay? And then set B also has what? 4 elements. They are finite because their last member can be found. Is that clear?
Yes, sir.
Good. Let us go to the second type of set. So if we have a finite set, who can give me the other type of set? Yes. Subset. You've done well. Yes, who else? Infinite set. Good. Yes. Empty set. Oh, you are good. Clap your hands for yourself. Alright. So we are going to talk about infinite set. Okay? We'll come back to what we were talking about, okay? So we are going to talk about infinite set. Infinite set. So having known the definition of finite set, I hope it's the other way around for what? Infinite. So who can discover to tell us what an infinite set is? Yes. Clap for her. What did she say? You. What did she say? You did not hear. You have to pay attention, okay? So infinite set is what? A set whose last member cannot be what?
Found.
Exactly. Yes. The last member cannot be what? Found. So who can give me an example? Yes, who can give me an example of infinite set? The last member cannot be found. Yes. Set B. 2, 4, 6, 8. Have you seen it?
Yes, sir.
So the last member here can, meaning that there are many other numbers. Do you get it? Now, when we talk of a natural number, okay, when you are asked to list natural numbers, can you list natural numbers to the end?
No, sir.
Wait to number 1, 2, 3, I could say
No, sir.
who can do it? Or maybe if there's somebody here who can do it. So it tells you that you cannot get the last word member. Exactly. So that set of natural numbers is what? An infinite set. But when we give you that, a set of natural numbers less than 10, see that one they have given you a cutoff point. Have you seen it? Natural numbers less than 10. And we see 10 when we, which is less than what? 10. So that one, it is not what? An infinite set. But that one is what? A finite set. Do you get it? But when we say set of multiples of 3, you cannot list all the multiples of 3 in this world. Do you get it? Good. So that one is what? An infinite. So the example that our friend gave is what? 2, 4, 6, 8. And then it is continuing with what? 3 dots, which is indicating that it is what? An infinite set. Please, have you got it?
Yes, sir.
Any question? Do you understand it? Yes, so now can you know the distinct or the difference between finite and infinite sets?
Yes, sir.
Who can tell me? Difference between finite and infinite sets? Yes. My good people, who can tell me? Difference between finite and infinite sets? Yes. The last member can be found. Good. Infinite set, the last member cannot be what? Found. Please, do you all agree with him?
Yes.
Good. Let us write. example, say set M is equal to 2, 4, 6, 8. Because the last member here cannot be found. Okay, so it is an infinite set. Somebody also mentioned another type of set, which was what? Empty set. Okay, empty set. As the name denotes. As the name denotes. Empty set. Empty set. Empty set, yes. Empty. But rather it is a set. So what is an empty set? What is an empty set? What is an empty set? You can't say empty set or anything. Your patches. Empty set. I hope you understand empty. So what does empty mean? What if you not a computer? When you someone that you can ask you, who may be a suana, be any. Charlie, what do you mean? Who will forget that? You take us a hungry one is an angry one. Okay. So what is an empty set? Yes. An empty set. Yes, compass. It does not what? Contain a member or any element. Okay? It is a type of set which does not contain any member. Okay? Every member here. It is a chance here is baby. So which has no member or element. Okay. So an example is maybe set Q. Example. So how many members has this set? It has no member. Okay. It has no what? Member. So this is what? An empty set. So always an empty set is denoted by what? This symbol. And there's also another name for empty set. Who can tell me? Yes. Another name for empty set. Yes. Null set. Clap your hands for that. Another name for empty set is what? Null set. So it is denoted by this symbol or something like this too. It is also an empty set. Okay. So another name for empty set is called what? A null set. Please, is there any question? Do you have any question? Alright. Let us take the next one. The next type of set we are going to talk about equal set. Equal set. Equal set. All of you say equal set. Equal set. When we say something is equal, what does it mean? How do you understand it? Something is equal. Yes. And then a pair. Okay. So let us see an equal set. So we say two sets are said to be equal if they have the same members. Two sets are said to be equal if they have the same members. So look at this scenario. Look at this example. For example, if we have set A, which is equal to 2, 3, 5, and set B. I want you to all look on the board. Please look here. Look at these two examples. What can you see? Yes, just observe it and tell me something. Write them in your books. Write them somewhere. Write the two sets somewhere. And then observe it. And then come up with something. Just take a critical look at the two sets. What can you see? Look at the members of the set. What can you see? Yes. Are you done? Then tell me something. What did you see? Yes. What did you see? You are on point, so see. So it's the same. Somebody saying that it is the same, but I have mixed them. You get it clear? Good. What can you also see? Yes. That's somebody's what idea. You have done well. Yes. Talk. You can see anything. Yes. It is the same. So now let us look at it. You can see that the elements which are here, we have what? 2, 3, and what? 5. But come to set B, we have what? 5, 2, 3. Are these elements different from these ones? Are they different? They are all the same, just that it has been what? Rearranged in different way. Okay? So the sets or the elements in set B are equal to what? The elements in what? Set A. Therefore, we can say that set A is equal to what? Set B. Exactly. So set A is what? Equal to set B. That's what we call an equal set. If the members are the same. Are you getting it? Say members not a pair. Members no more set A no. Or more no more set B. For example, in Kauba class A be a high A. Members no more set class A no. Over B now or more sense. Do you get it? Do you understand it? So that is what we call an equal set. The members here are what? The same. We have 2 here, we have 2 here, we have 3 here, we have 3 here, we have 5 here, and we also have what? 5 here. Do you get it? Therefore, we can conclude that set A is equal to set B. Is that clear? Good. So, we can say that A is equal to B. A is equal to B since the members in A can be found in set what? B. Since the members, or you can say all the members, okay? Since all the members in set A can be found in set B. Let us take our last type of set. The last type of set. That is equivalent set. All of you say equivalent set.
Equivalent set.
Again.
Equivalent set.
Equivalent set. Just want to two sets are said to be equivalent if they have the same number of elements. Please stop writing and look here. There's a difference between equal set and equivalent set. Let me put the examples there and then you get to know it clear. For example, if we have set A, how you can see from this side. If we have set A equal to 2, 3, 5, and then set B is equal to 11, 12, 13. From the definition, we are saying that two sets are said to be equivalent. Please stop writing. Two sets are said to be equivalent if they have the same number of what? Elements. So you have to put this one in mind. The same number of what? Elements. But when it comes to equal sets, if they are what? They have the same members. Have you seen the criteria? Equal sets have the same what? Members. But the equivalent sets have the same number of elements. So how many number of elements are here? 3. This set B also has how many number of elements? 3. You get it clear? But look at the members. Are they the same? So this is what we call an equivalent set. They have different members, but the number of elements within the set are what? The same. Okay? And you both football match. Ebia, St. Augustine versus demonstration C. Obia, they have many members in the number? 11. But my players number one, I send you one about demonstration for. Have you seen it? And so you all have the same what? Number of what? Players. 11. So it is what? An equivalent set. Please, do you understand it? Yes. Good. So we are going to end it here. Okay? Good. So what have we learned today? Yes, what have we learned today? Yes. We can't hear you clearly. You have learnt about a finite set. And what is a finite set? It is a type of set whose last member can be found. Yes. Who else? What have you also learned? Yes. What did we say an infinite set is? What is an infinite set? Good. Cannot be found. Good. Clap for her. Then what other type of set again? If somebody has talked about finite, infinite, yes, what else? Empty set. What is an empty set? It has no member or element. You have done well. What else? Alright. So you've done well. Take this exercise. Let us take this exercise. So next week when we come, we are going to talk about subsets and the number of subsets. Okay? So when you go home, you go and then read about it. Read ahead. Is that clear? Good. It will help you. The more you read ahead, it helps you. So take this exercise with them. And I hope you are done with this place. Yes, stay. Alright, so thank you very much. We have ended the lesson. So we shall meet the next time. Bye bye.